Welcome back. This is section 6.2 teaching video, and 6.2 is 5.2 in your textbook. We are talking about the fact that a force can cause acceleration. We're heading towards Newton's second law of motion, and I've already kind of spoiled it. Newton's second law of motion is that force equals a mass times acceleration. We've seen already that force is going to be directly proportional to acceleration. So if you increase a force on an object, you can accelerate it more. So imagine kicking a football, and you can, while it's touching your foot, you can accelerate that football. You can make it go faster. Well, let's say you kick it harder. You're going to accelerate that football even more. Let's say you're stronger than someone else. You could kick that football farther than someone else. Superman could kick it very far. So we're going to see now that not only is force directly related to acceleration, but acceleration is inversely related to mass. So let's say you made that football bigger, or even changed the football for a bowling ball or for a boulder. Suddenly that same kick would probably break your toe or your leg, because you can't accelerate that bowling ball the same as you accelerated the football. So that acceleration is going to be less the more massive that object is if the force is the same amount of kick. If you're kicking it as hard as you can and it's something heavier, you can't accelerate it as much. So if you're throwing a baseball, as long as the baseball is in your hand, touching your hand, and your hand is shoving that baseball before it releases, you're accelerating that baseball. If you were to, say, have a wiffle ball or a ping pong ball, that same amount of force could accelerate that ball faster as it's leaving your hand. Now, the air resistance wouldn't let it go as far, but the actual acceleration, you could make it go faster, have a higher acceleration than the baseball would. And if you try to throw a bowling ball, it would be exactly the opposite. The more massive the bowling ball means that the acceleration is less. So, put simply, mass resists acceleration. Now, this is Newton's first law. If you remember Newton's first law, that inertia is related to mass. The more massive something has, the more inertia it has, and its inertia is that an object in motion wants to stay in motion because it's got an inertia. An object at rest wants to stay at rest because it has inertia. Inertia is kind of like a laziness to changing its motion. So it doesn't want to change its motion. And the more massive it is, the more it doesn't want to change its motion. Okay? The easier it is to throw if it's lighter, less massive, the harder it is to accelerate or change its motion or stop. Imagine something is being thrown at you very, very fast. It would be very hard to stop it. If it were thrown slowly, it would be easy to catch it. But if something were thrown very fast at you or shot out of a gun at you, it could kill you. You wouldn't, I could catch a bullet if you threw it at me, but don't shoot at me. So acceleration depends on the mass. So the more massive, the less the acceleration at the same force. So we have another proportional sign. Only this time the proportional sign is not to mass. So mass is not proportional to acceleration. As one goes up, the other goes up. But it's proportional to 1 over the mass. So as one goes up, the other goes down. Now, if I were to put this back in Newton's law, which we'll see it later, and I want to solve for mass, okay? If I want to solve for mass, then you'd have to divide by acceleration. If you want to solve for acceleration, you want to divide by mass. So if two things are on the same side of the equal sign, as one goes up, the other is going down. So if mass goes down, my acceleration could go up at the same force. If mass goes up, my acceleration goes down at the same force. Okay, so a inversely proportional, you need to know that term. Inversely proportional means as one goes up, the other goes down. And the mathematical way to say inversely proportional is acceleration is directly proportional to 1 over the mass. Okay, that's the same as saying it's that the mass and acceleration are inversely proportional for each other. So the acceleration produces depends on the mass that's pushed. So how does an increase in mass affect acceleration? You make something more massive, is it easier to accelerate or harder to accelerate? You think about that.